Welcome to the Air Pollution Control IIoT and Remote O&M webinar this morning. And we're going to start sequencing through the PowerPoints here. But first, these are the people who have signed up today, and only several of them are already on the phone, and more of them are participating as we move along here. So. But if anybody has questions as we participate, as we move through this, please don't hesitate to ask questions or make comments. The IoT for air pollution control is actually a $30 billion opportunity for the industry by 2026, and that seems like a huge, unbelievable amount. But the way we've calculated that is that we think 50% of the revenue potential is from increased purchases, that suppliers will be providing products that are IIoT shaped, or delivered, or influenced. And the other 50% is from purchases that would have been made anyway, but are now made through a different route. And so we see a lot of sourcing by the large end users buying for all their plants, and for third parties who are remotely operating and controlling the plants, and they would be the purchasers in many cases. So a lot of that is already happening. We had a gas turbine webinar where we showed that third parties are already operating many of the gas turbines, and of course the turbine suppliers are continuously monitoring all their turbines already in all these locations around the world. But filter bags, valves, fans, conveyors, and all these other components, continuous emissions monitoring systems, reagent delivery, all will be monitored and serviced through the IoT ecosystem. So in the new IIoT environment, the fan and valve suppliers will be viewing health data on their products through the cloud. So the APC supplier has the opportunity to become the operator of all this, or he can abdicate and let a digital process management company such as Accenture, or the plant suppliers such as GE, or consulting companies such as AECOM take the lead role. And in any case, there's an opportunity to work with any of these third parties, or to become one of the third parties. Or so there's actually, then there's in between too, which is to be a third party in collaboration, as you'll see a number of examples here. So we do think that a large portion of the air pollution control systems in the future will be remotely monitored and controlled. And the cloud-based systems will also supply continuous data on all the major components to the supplier of that component. So if you're operating an air pollution control system, the fan manufacturer and some of these other people, as well as the equipment manufacturer, are going to be continuously seeing this information. And I think what's very important here is that there will be a tier-based solution for problems. So for simple problems, the operator will provide the answers, the operator of the remote control center, or refer to a generalist at the supplier company. But for the difficult or more important problems and opportunities, the operator will bring in subject matter specialists, which is the term that the industry is using. But we think that's greatly underestimating the potential and the need. And so we actually have renamed this really as the Industrial Internet of Wisdom, and that just instead of bringing in subject matter specialists, you have to develop a whole Internet of Things type wisdom service, and that is going to be a big opportunity for air pollution control equipment suppliers. And basically, they will be making money on knowledge as well as on the products that they sell. Part of this development of the IIoW is organizing purchasers, suppliers, and knowledge. And in terms of organizing purchasers, we've got a beta site for Berkshire Hathaway Energy. So all the air pollution control equipment in all 200 of their plants and compressor stations where they have gas turbines and so forth is all in one organized database. And so you can see whose filters are where. And Hamon's got filters at Huntington, and somebody else has the filters at one of the Mid-American boilers, et cetera, and who's got all the catalysts and who's got all the other equipment that's in all their gas turbine emission control systems. So putting all that in one place and then having case histories and documentation as to what's working well and what isn't is essential to taking advantage of all this sensor data that's coming in, because when the sensor data comes in, it tells you the status and maybe of all the existing options, what's the best, but it doesn't tell you what new option there may be to solve the problem. And that's where the wisdom comes in. So the, all of this is certainly in the embryonic state, but I think we can all agree that the potential is for the IIoT to open the door for faster adoption of newer and better technologies. And I've been in the industry for many, many years, and there was a go-go period when the Clean Air Act was initially promulgated, and new technology was developed on the same kind of rapid scale that you see in Silicon Valley. But when that all dried up, it's gone down to a trickle. In fact, in many respects, you might argue that more development was done in that 5 or 10 year period than's been done since. And strangely, a lot of the technology in Europe and Asia is merely been an adaptation of existing technology rather than new technology being available. But I think when you're sensing everything continuously, you're going to develop all sorts of insights about how to do things better. And then with the wisdom, which does show you how things can be done better, you're going to move to new technology. And an example of that is the webinar that we did do for Berkshire Hathaway Energy. We hosted 9 hours of webinars, and they have a commitment to put in NOx control equipment, and their consultants and EPA estimated it was going to cost $700 million. But with presentations by GE, Siemens, Doosan, Emerson, and all on the optimization systems, so all on the IIoT type approaches to getting NOx down, you do get a substantial reduction in NOx. But what we also found was that there were some novel equipment approaches that would be particularly successful in those two plants. And so with all this, they probably are going to be able to eliminate conventional SCR and save more than $200 million a year in capital costs and $15 million per year in energy consumables and repair. And that was really just because of the wise crowd decisions that are a part of this IIoW. Thermal gas treatment is certainly an area where IIoT is already being employed, and you've got a number of reasons to do it. If you've got the RTO systems, you have 3 cans and you're continually diverting the flue gas into each one of them, so you've got all sorts of complexities there. With catalytic oxidation, you've got some pretty sophisticated oxidation challenges, in many cases toxic fumes, and so that has its own set of needs. So the emissions from these systems are already measured and are already being streaming to remote locations such as government agencies. So this is the IIoT base from which to expand. And some of the companies are moving forward. Arion has got an agreement, collaboration with Honeywell, and provides complete systems, as we'll see in a minute here. So the Arion automation service is pretty extensive. Megtech is another one that we'll get into in a minute. It's part of Babcock and Wilcox, and they are able to help customers actually choose whether to burn their solvents or recover them on a daily basis. Fabric filters is another really big opportunity. The way it operates now, most of the decisions about replacing bags are made as sort of a splintered basis. The bag supplier is a major cog in all this, but with IIoT, the equipment suppliers are going to be able to be monitoring the performance of their systems on a continuous basis. So they can manipulate the system to maximize bag life as well as performance, and therefore they're in a better position to guarantee the life of the bags than would be the bag supplier. And the opportunities for the end user, of course, are to, first of all, not have to remotely, not have to operate and control the systems themselves, but also in the savings in bags and some of the other consumables that you would achieve. Now, the bag suppliers will benefit because there'll be, the continuous white papers on the performance of individual bags, and therefore those bags that are performing well will be recognized and potentially higher revenues achieved by those suppliers. Power plants have the largest IIoT opportunity for SO2 and NOx control. Yara has a NOx reagent monitoring system, for instance, all the gas turbine emissions. We have whole websites devoted to emission control in coal and gas turbine plants, and there's many opportunities for better IIoW, our wisdom applied to the industry in the air pollution control stages. We do even think that the two-stage scrubber can actually provide rare earth feedstocks more economically than any other option that exists right now. Electrostatic precipitators are a particularly interesting case because they are being monitored remotely in many plants. So that really would be the first step toward, optimizing the performance of the complete air pollution control system from a remote monitoring center. We talked about the VOC monitoring here, and Honeywell and Arion are collaborating, and they are marrying, of course, their digital process information expertise with the Arion knowledge of the flaring and combustion, and it's being applied fairly widely here. And the deliverables are the obviously all the software, the wireless systems, startup and installation services, automated emissions and reporting, and remote diagnostics. And this can be augmented, and this is where the additional revenues come in, because this allows the equipment supplier to control the aftermarket parts and also the service. And the industry is certainly moving along in this regard. Just one kind of a benchmark is that there are now tankers moving oil and other goods on at least trial basis between ports with not a single person on board. So some of our clients that make the centrifuges and the pumps and the other equipment that's on board these ships are monitoring the performance remotely. And if there's a centrifuge failure, there wouldn't be anybody aboard the ship anyway that would know how to fix it. But once the alarm sets in, you can send a helicopter, do whatever you need with the person to fix that. But having people aboard those ships doesn't serve a purpose when it's all automated like this, and you can save about 30% in the cost of moving goods. So back a little bit more on some of the Arion things. I think we've already gone over what they can do. Coke has a similar system, and they can monitor in real time all their vapor control systems, and so they're in a similar position. DERA has an effort in this area as well, and here's an example of a precision coating company that's making durable films. And with the approach that was taken here with this small company was even more comprehensive. They funded the project, and Soliant agrees to pay DERA a fixed monthly fee from the natural gas savings generated by the RTO replacement. So there's bonuses for exceeding the guaranteed efficiency and penalties for falling short. So, but with the 24/7 monitoring, the DERA can save the company money and make more money themselves. So again, this is where the air pollution market expands. By the way, any questions anybody has as we move along here, I would certainly welcome, or challenges that you may have some opposing views, feel free to mention them. A lot of the technology is in the components themselves. So nozzles in your scrubber and sensors for flame measurements and oxidizers, tunable diode lasers that measure the CO and oxygen in the boiler. All these things are necessary components, and so improving all those components and so they have reliable sensing that's going to the remote center is important. And LumaSense is one of the examples that we used here. So we have whole 9 hours of webinars just for Pacific Corp on the NOx subject, and then we have a whole website devoted to a lot of presentations by the SCR and the Catalyst people, and then people that are providing the optimization systems. And so I just wanted to put a few examples in here on the system solutions. So Siemens, by the way, they bought a TDL or licensed TDL technology, so that they're able to measure the O2 and the CO in every part of the boiler and make the adjustments. And they have comprehensive digital process management solutions based around combustion optimization for the boilers. They also have things like the variable speed drives, and I think this is for these large corporations, they really need to be coordinating between the people making the drives and those providing the optimization systems, because the optimization is a function in many cases of being able to control the fans and the pumps and some of these other components more precisely. Emerson is involved in everything from the valves and pumps to the complete systems, and they have the silo optimization system, and so they're in a very good position, and they're very involved in the digital process management. And in fact, in our 9 previous webinars, there are many slides on Emerson that have been discussed. The Emerson system at Ameren actually gets down to the 0.085 pounds per million BTU within the boiler itself. And so if you can do that, then it's possible to go to the rest of the way without a full-scale SCR system. And that was a part of what Pacific Corp was pursuing in our webinars. Uncovered was the opportunity to do that with things like ozone injection into the scrubber, which is being seriously considered right now. So it does seem like to be an intriguing opportunity, and particularly in India, where right now you have a large number of old boilers for which NOx control, particulate, and SO2 has to be applied. In fact, there's over 100,000 megawatts of boilers in India that will be candidates for all this. The suppliers of the consumables play a big role in all this too, and they can have their own remote control centers, but it can be integrated in the cloud with the complete system management. So Yara can monitor the amount of reagent that is in the tanks and the amount that's being used, and can compensate with additional changes in their deliveries to even out the supply of their reagents. So they have the complete potential to also do the temperature, pressure, and actually add chemical sensors to it. I wanted to get into some other examples. The one of whom would be Daikin, because Daikin has American Air Filter, they've got Flanders, and they have HVAC divisions and air conditioning. And essentially all of it can go together and should go together in most industrial plants. So you take the average industrial plant, it's got dust collectors, it's got the need to condition the air for all the people in the plant. So you have a lot of HVAC. And so we're going to be showing some examples about how they're already into the IIoT for HVAC, but in the case of a very sugary dust condition in a plant, they solved it in a way that maybe that with IIoT they could have better solved it. And again, the dust control, exhaust air, heat recovery, recirculated air, and makeup air are all interrelated. So the company has a fusion program that touches on all this, and so we've just taken some of their slides on their fusion program and added our comments about how IIoT can enhance all that. So the company actually is doing very well, and by combining HVAC, filtration, and dust control, and they have been really moving ahead with IIoT for HVAC. They're using Intel systems for end-to-end analytics, and Daikin Applied is able to efficiently connect its Rebel units to the cloud and securely aggregate, filter, and share data. So they're able to assist and proactively manage building performance and the awareness of heating, ventilation, and air conditioning issues before they happen. So for preventive maintenance standpoint, they also have software from Wind River, and of course with McAfee on the security. So enabling the advancement in service and development of energy management systems with end-to-end IoT application solutions that are efficient and secure. And the cost of these systems is relatively low. Of course, they can apply this to a huge HVAC base. But they see the deployment of value-added services such as real-time HVAC unit performance, remote diagnostics, monitoring and control of energy management, and third-party content integration. So they are well into all this, and with 40% of the building energy expenses tied to HVAC operations, for an industrial factory owner as well as a commercial building owner, the HVAC becomes a critical part of the cost of the operations. And their intelligent equipment provides direct access to 150 data points. So it's a robust system. So the overlap with air pollution control is that things like filters and fans are already monitored in their intelligent equipment platform. So specifically the Daikin Rebel and Daikin Maverick 2 technologies interface with newer legacy equipment, and they measure the performance of the fans and the pressure drop across the HVAC filters, and therefore the taking that and doing the same thing for dust collectors should be, and as we'll see, dust collectors are often and typically in the same plants with the industrial ventilation HVAC. So their program is designed for the applied HVAC as well as residential and commercial, and that's where they can integrate their pollution control services and certainly provide sourcing as a service, all the replacement filters in the plant. Their fusion program targets China as a big market, and it is the largest air pollution control equipment market right now, particularly on the repair parts, because they've just put in nearly 1 million megawatts of air pollution control equipment for their power plants. And the HVAC filter market is huge because, number one, it's a billion people, but number two, the ambient air is so bad that you desperately need the best filters, but also that you need to replace them more often. So it is a target market for both. And in each industry, you're layering one thing on another. You have all this technology for the air pollution and HVAC, but also for the process equipment. And they're targeting the power industry, which we've just been talking about here, pharmaceuticals and other industries. And so you've certainly have clean rooms in a number of these, certainly in the pharmaceutical plants. And so that opens the door for some of the other Daikin product where they're making a lot of PTFE media, and there's all sorts of places in clean rooms that is necessary. But the indoor air quality monitoring will also provide the data to design better hoods to capture fumes and better ways to recover heat. And the devil is in the details. So Daikin, through AAF, for instance, furnishes fan filter units. So what is a fan filter unit? Typically, 20 or 30 years ago, all clean rooms were what they call ballroom clean rooms, and there was a layer of filters all the way across the ceiling in a very clean room, and you had one fan that blew the air across all the filters and then down, trying to achieve laminar flow at about 100 feet per minute down from the ceiling to the floor grates and then back again. But what it was found was that if you have a little 1000 CFM filter, over every 2x4 filter unit, a fan over every filter unit, which they then call a fan filter unit as a combination. You can control every 2x4 section of your ceiling through one fan. And so they've gotten the price of those down to where it's not a whole lot more money to put in, 1,000 fan filter units than it is one big fan, and with the filtration systems. So this then gives you the flexibility to adjust the airflow within the clean room to suit the conditions that are in the clean room. And we've been involved in that to some extent, and we have been looking at the research that points out that the actual cleanliness in the clean room is to a large function related to the movement in the clean room rather than the basic cleanliness of the room. You got people moving around there, whatever dust there is there gets stirred up. So in the future, I think there's even going to be more emphasis to controlling ceiling air more precisely based on the movement within in the room. So they can also leverage their knowledge in heating and energy recovery. And from the air pollution standpoint, the development of the new catalytic filters at 850F provides a clean hot gas stream. And for many air pollution control systems, this is a revolutionary opportunity. You can get clean air at 850 degrees. You don't have to cool it down to go through a dust collector or, at 300 degrees and lose all that energy, or in many cases to go through a scrubber where you have to cool it down to, it cools itself down to 150 or 160 degrees, and then you got this big vapor plume. So with the catalytic filters, you get a clean hot gas stream. You can go through a heat exchanger and you can recover that heat. And the importance of that might be underlined by what GE now predicts, that the future is going to be small power plants in the 100 megawatt range. They've even gone so far as to predict that sometime in the future we'll be back to where we were in the 1900s, where the average power plant was only 100 megawatts and providing distributed energy and combined heat and power. And the reason for that is that you double the efficiency of the plant. But that does highlight the importance of the energy recovery. Any questions at this point before we move on here? So Daikin is already moving forward in a lot of this, and even into things like the BioClean and biopharmaceuticals. And this is where it gets very, very critical to be managing your environment on a holistic basis, and probably even reap bigger benefits from the IIoT. Certainly, there's lots of opportunities that are opening up for Daikin to provide the sourcing for all the HVAC air pollution control products. And we believe that marketing and product development will be shaped by IoT more than the other way around. And the sourcing is going to be global. And companies like ArcelorMittal, who has 200 steel mills and coal mines and iron mines scattered throughout the world, they're already moving in that direction. And so they are globally sourcing products. And when they do that, they can take the time to do the total cost of ownership studies. And the total cost of ownership studies are greatly enhanced by having all this IIoT data, which shows which products are working best where. So I think here's a perfect example. A food manufacturer in Michigan was experiencing short life on his HVAC filters due to sugar dust. Daikin conducted an HVAC audit and recommended an HVAC filter change. Switching to a deeper pocket filter from AAF increased the filter life from 2 weeks to 5 weeks and saved $24,000. But if you start doing the math, they're still spending a lot of money per year on filters. Plus, imagine if you've got a sugary atmosphere around there, what's happening to all the motors and fans and other and process equipment. So our thought here is with the fusion strategy and IIoT, the sugar dust would not be in the atmosphere causing the problems. With better local dust control at points emitting sugar dust, there would be hundreds of thousands of dollars saved. So instead of just doing a plant audit, you're looking from your remote control center at any point in time into all the air intake, recirculating air, HVAC, and so forth. And you're not only providing these filter savings, but lowering the maintenance on all the equipment and, of course, the energy savings and things as well. So Daikin owns AAF that provides dust control systems. And in Europe, they've been pretty active supplying furnace control systems. But this is a further opportunity because when you look at one of these furnace control systems, you're pulling in lots of ambient air in order to control the fumes that are being generated by furnaces and ladles and all sorts of different things. But these can be intermittent, and certainly at times during the night, possibly there may not even be in operation. And so with variable speed drives, you can be controlling the amount of air that actually goes through those hoods in order to maximize cleanliness, but minimize energy consumption. And with the triboelectric particulate monitors that can monitor fugitive dust, you can actually be assured that you can maintain the cleanliness that's needed in the area. And then there are temperature and humidity variables and things, and Daikin already has in their IIoT program the weather predictions even that are taken into account in their IIoT. So all of this can be balanced too, because for every CFM of air that goes through these hoods, there's another CFM of air that has to come in through your makeup air system. And of course, the weather can be a factor as to whether you want makeup air in there to make the temperature conditions within the plant better or not. So, yeah, the way to look at all this, I think, is that by a holistic approach, you vary the amount of exhaust air that goes out through your dust collector systems based on the cleanliness and some other factors. You eliminate certainly the drafts and all these other things by maintaining a pressure within the plant that is as close to zero as possible or slightly positive. And that things like the oil mist, you have the local dust collectors which collect those. And in some cases, all the exhaust goes outside. In other cases, it's all recirculated, depending on the type of dust and conditions and so forth. And then you look at everything else within the plant too, and all this can be remotely monitored and controlled. There are some other examples here would be FLSmidth, which has a huge opportunity because they're already the equipment supplier of many of the cement plants in the world. And so you've got their opportunity to leverage that. They supply replacement bags. They supply bag collector systems, precipitators. They do have acid gas control equipment, and they already are providing 24/7 global support, advanced troubleshooting, remote software maintenance, and all these different things. So for them, they're going to be, if you're potentially competing with them, it's going to be a formidable competitor, and would heed you to be part of a system yourself that can provide all these different options, all as part of an integrated system. B&W is another potentially big player in all this, although they have not put together any of it in a comprehensive way, but they do have a MEGTEC subsidiary that does provide pollution control equipment for industry and has spare parts programs. And of course, B&W is a leading supplier of boilers for power and other industries, including waste energy plants. And it would seem to me that there's a huge opportunity for them to step into this business now. And one reason it has a problem, B&W does, that its human experts are centered in the US, where its growing markets are in Asia and developing countries. With remote monitoring and control, B&W can take advantage of all the expertise in Barberton, Ohio, De Pere, Wisconsin, and other locations in the US. They have, on a maybe less than completely organized basis, they have all the different components to put together the IIoT systems. They've even been into their all acoustic leak detector system. Here's a unit that was successfully put in at Alabama Power here in the early 1990s. They bought the continuous emissions monitoring and precipitator products that were offered by BHE General Electric. And so they are continuously monitoring with their SEMS the power plant emissions around the world. And they've got all the software tools to provide data reports, system condition alerts, and fleet analysis. So that is another quiver in their, arrow in their quiver. And they are, with their MEGTEC division, they're doing this for the chemical companies that are burning solvent fumes, or in some cases regenerating, using a solvent recovery system to recover them. And so a MEGTEC can help the plants on a day-to-day basis, depending on which solvent they are going to be using that day and the price of that solvent, whether to be combusting it or to be running it through the vapor recovery systems. So these systems that are being supplied with the Yokogawa type support give them a secure format to review all the performance of these systems and to analyze it. So they are remotely monitoring their waste energy plants. They own Vohland that works out of Europe, supplied a number of waste energy plants. And they're using Metso DNA automation systems, information management. And so that is one step along the way to the remote IoT for all of the components in the plant. Training is another opportunity here, and this can be online training, it can be training in support of all this, but the digital opportunities for training are substantial, and someone like B&W, who's actually offering face-to-face training, has the opportunity to integrate this with the IIoT and to be training people along with the data analytics and things. So in other words, you not only have the basic training, but with the data analytics of what's going on at the plant, to do advanced training for the operators of that plant based on the data analytics, which are certainly a big part of all this IIoT. So the newest acquisition, which is just a month or so ago for B&W, was the Universal AET, and this gets them into the engine emission control and filters. And this is an interesting opportunity. We've been doing a pretty deep dive in this whole area, and one of the big opportunities is actually indoor agriculture. That and you take a plant like Pacific Current Creek plant, they're actually growing 22 million pounds of tomatoes per year with CO2 from the Current Creek gas turbine. And what has long been known is that the more CO2 there is in the atmosphere in a greenhouse, for instance, the faster plants grow. And by the way, one of the big arguments about Daikin's doing anything about global warming is, and 30 universities have banded together to show that the Earth is considerably greener now than it was 20 years ago, and just this slight increase in CO2 in the atmosphere is what they're attributing to this satellite greenness that is now quite apparent. But Caterpillar and Cummins and a number of the other suppliers, GE is a big proponent of this indoor agriculture with these engines. And what's intriguing about it is, whereas at Current Creek you're using just part of the exhaust from a large power plant turbine, in these indoor agricultural facilities you have a small gas engine, and then maybe not so small, but a gas engine, which delivers the heat, power, and so forth for the greenhouse, and also delivers the CO2. But from an air pollution control standpoint, you then have to clean that CO2 up to a level that you don't have to do if you're just discharging it outside. So these the basis, by the way, of GE's projection that most of the power will be generated by distributed generation is in part due to what can be done with your gas turbines, as well as, of course, solar and wind. So the acquisition of Universal AET, I think, also extends the B&W opportunity here. So these are the aspects of it that we have provided in the slides here. I did just want to show one more thing, which was the collaboration. And this is a news release that we have just coming out today. Just open that up a little bit here. So I think what's fundamentally going to change is the need for collaboration among divisions within large companies, among end users, among suppliers. And we visualize even the small companies collaborating with other small companies and with large companies, so that there's a holistic approach to a lot of the problems. And you have anything but that right now, particularly with some of the smaller companies. They've got a whole hodgepodge of reps out there talking to customers with a very uneven type results. But what we would say is that the need to coordinate your sales activity is going to go up by an order of magnitude. And prior to IIoT, the way most products are purchased is haphazard. And so a supplier who has a haphazard sales program isn't going to suffer much because the whole process is haphazard. A few products are purchased based on total cost of ownership analyses because of the high cost to benefit ratio for one-time purchasers. Purchasers do not perceive the potential benefits of multi-products synergy, but all this changes with IIoT empowered by IOW, because the IIoT will make it possible for purchasers to easily coordinate all their multi-plant purchasers, and ArcelorMittal being an example. They just purchased 4 dust collector systems for South America and for steel mills in Europe, all in one purchase order. So there's certainly many of the individual companies have tremendous synergies. So Colfax, Howden monitors the fans, but they can also be monitoring the lubrication pumps and a number of other of the Colfax products. So it's imperative really for Colfax to have more synergy between all these different divisions. And Netterman and Seco are certainly other examples of companies with many different divisions that have different representatives, go to market in different ways, but they have both the opportunity and probably the pressure in the future to coordinate this on a different basis. And so they need to coordinate, and even to just focus on the individual customers who are coordinating all their activities. And we're trying to further all this by helping some of the end users organize systems. And the Berkshire Hathaway Energy Supplier and Utility Connect does identify all the components at 200 power plants and compressor stations owned by BHE. And so it means that if you're selling to the Mid-American plants in Iowa now, and Nevada Energy with somebody else, and somebody else with Pacific Corp in Utah, that you're going to need to organize your people, because the very good possibility that this is all going to be centrally decided in the future. But with the IIoW, you also need this wisdom. And so we have a number of initiatives going that actually provide decision options. And for instance, the example, we had to get the catalyst people together to determine how do you actually keep and maintain catalysts. And it turns out you've got cleaning, rejuvenation, and reimpregnation. So you've got really 3 ways to treat catalyst. But actually providing what those options and what the cost of them are and how often you need to do what is the types of things you need to get into in these decision systems. The one on coal-fired boilers has separate NOx control, FGD, and power fabric filter type decision guides there. And we also have systems for helping plants coordinate their strategy with a very detailed forecasting of markets and these major prospects. Just a few companies in every industry in the major countries basically are the market for most of the suppliers of air pollution control equipment. And then things like with our 4-lane knowledge bridge to the end user, we believe that the recordings, we call them interweb views, of your sales people are the key to, and putting those up on YouTube are the key communication tool for the digital future. And that for every $1 million in sales a year you have in a product area, you should have a one sales presentation recording. And of course, that doesn't take much expense because you're already put the PowerPoints together. The salesman's already using it somewhere, so it's just a matter of getting it recorded and putting it up on YouTube. So that ends my presentation for today. I would welcome any questions before we sign off. If not, we do have a clean room session next week, and then a number of ones, actually one on each area of IoT going forward, and invite you to join us. And so this is Bob Mcilvaine signing off for today.